second video of this series of designing a notification system. So in this video we'll be diving, or we'll be rather looking into a high level design of a notification system. So in order to discuss this section, we'll be looking into three parts and eventually discussing each part in details. So what is this? Like different types of notification. Second is we have contact info gathering flow, and the third we have notification receiving or sending flow. So now we will be looking into each of these sections in details. What are these actually denote, and what are they? What is the underlying thing in these sections? So first is like different types of notification. So in the previous video, in our introductory video, we have discussed about various notification system like mobile push notification or SMS notification or email notification. So like the mobile push notification, let's say this is one of the type of notification. So in mobile we have mostly two operating system. One is the iOS devices and the other is the Android devices. So let's say for iOS devices we have Apple push notification service, or you can call it as APNs, Apple push notification service. So basically so we have three different components, primary components for a push notification to work in an iOS device. And what are these? Are like, one is the provider. So what is a provider? What is the role of a provider? So it basically builds and sends the notification request to the APN. So basically it triggers or it builds the notification and it sends the notification to the APN. And what does it comprises of? It comprises of, let's say, device token. So this is the unique ID used with push notification. And the other thing which the provider comprises of is the payload, which is basically the JSON data dictionary. This is the JSON dictionary which contains the notification, contains the body of notification. So basically these two are required. So these two are provided to construct. So what are these two used for? To construct the push notification. Provider provides this data. Okay, so this is one of the component of a iOS device push notification. After this provider, we have another thing is the APN. So the provider basically it as we see, it builds and sends a notification request to the APN. So once the notification has been sent to the APN or the Apple push notification service, so this is actually a remote service by Apple, and its main work is to push notification to an iOS device. And the third, or the end user which receives the notification, is an iOS device. So they are basically the end user or the client which receives the notification. So if I just draw a flow diagram, so what happens is like we have a provider. So it basically builds and sends a notification to the APN, An API in turn forwards this notification to an iOS device. So provider has basically two sections. One is the device token, which is a unique ID associated with a push notification, and along with that it has a payload, which is a JSON dictionary, which basically contains the notification. So now we have seen for an iOS device. Similar thing happens for an Android device. So the way the notification is being pushed to an user, Android user, similar flow happens, but instead of Apple push notification service, here we use a Firebase control message cloud messaging. Sorry, a Firebase cloud messaging. This is a remote service provided by Android to forward notification to an Android user, or in acronym format you can say FCM. Similarly for SMS, so this is for this we covered for mobile push notification for both iOS and Android devices. So the second type was, if you remember, it was SMS type. So for SMS we have a similar flow, but instead of an APN or an FCM, we have a third party SMS service like Twilio or Nexmo, etc. So I'll provide the links about them to read about them in details in the description box. You can check them out. And the third is like the emails. So similarly, the notification flow is similar in all these cases, except the third party service which handles the pushing of notification to the end user. So here in emails we use SendGrid or MailChimp. So these are third party email service providers. So their usage can be, apart from sending notification, they can be used for data analytics, and they also help in better delivery rate. So this is the first section of the high level design. So different types of notification. So one, we have the mobile push notification. The second, for this we have both iOS device and an Android device. And second, we have the SMS. For SMS the flow is similar, except we have a SMS third party service provider, which is, let's say, Twilio or Nexmo. And the third type of notification is an email notification, and for this we also have third party email service providers, which are SendGrid or MailChimp. So now let's discuss the second section. So the second section was contact info gathering flow. So we'll discuss this section by asking two questions. So the first is like, what can contact info do we need to gather? So basically, to send the notification to a mobile device or in format of SMS or email, so what information do we need? So for, if suppose this is a push notification from an application, so for that what we need is like, we require a mobile device token ID, right, for mobile push notification. Basically this is a, for a mobile we need a mobile device token. Let's say for a laptop or a desktop, whatever device we are using, we require their token ID to send the notification correspondingly to that particular device. So this is a mobile push notification. Suppose we want to send an email or an SMS to a particular user. For that we require the phone number. For SMS we require the contact number. For email we require the email ID of the user. So these are the basic information, like the mobile device token, the contact number, and the email ID, which we need to gather. And the next question is, how do we gather this info? How do we gather this info? So suppose for this mobile device token, so what happens whenever a user installs the app or signs up in a application, API servers, what they do is, API servers, they collect info and store this in the database. So they collect info and store in database. So suppose I have installed an app and the first time I am signing up or logging in into that app, so I need to register myself, and while registering I provide my information, let's say my email IDs, my contact information and all. So whenever first time I am registering in that app, the API servers, what they do, they collect that information and store in the database. So basically it has been found out that in database we store these information in two different tables. So in database we have two different tables. One is the user table, another is the device table. And why this is so? So for a particular user, we have, let's say he has his own email ID and own contact information, and that particular user can install that application in multiple devices. So we need a device ID for a mobile push notification to send for that particular application to notification to all the devices for that particular user. So it has been found out that it is beneficial to store the database in these two different tables, and there is a one is to many relation between this. For a particular user there can be multiple devices, so we'll have a one is to many relationship between them. So this is how we gather the information and store in a database. So if we see in a flow diagram, so this is a user, so he or she signs up in the app or installs the app through a load balancer. What we do, we distribute this load to an API server, this request to an API server, and API server in turn saves the data in a database. So in this way we collect the information and store them in the database for our future purpose. So now let's look into the third and the final section, which is our notification receiving and sending flow. Notification receiving and sending flow. So we'll understand this with the help of a flow diagram. So we have, let's say, server 1, server 2, and there we have n services, and they all trigger a notification and send this notification to a notification system server. This in turn sends the notifications or the request to a third party services, so which we just discussed in the different type of notification section. One was the APNs, then FCM, and then SMS, then email, all these third party services, which in turn forward the notification to an iOS device or an Android, or this is a message, or this is an email. So this is the high level overview of how a notification flow happens in a scenario, in a particular scenario. So let's now discuss each of these individual sections, each of these individual components in details. So what is this S1, S2, Sn? So basically these are microservices, or you can say cron jobs, or distributed systems, which triggers the notification, sending event. So let's say for example like billing service, like your payment is due by this date and all, so as a reminder you send the notification in a particular period of time, or like you have ordered a product on e-commerce and they send you the shipment details or the product details or the order details, etc. So these are these microservices which triggers the notification sending event. After that we have this notification system. So what is this notification system? So what is the role of this notification system server? Notification system server, it acts like it's like a central part. So basically it receives the notification from the services, microservices, and sends the notification to the end user through the third party application. So it's like a central part which like receive and send notification. Its main purpose is receive and send notification. And how does it do it? So it exposes or it provides API to, and what it does is like it provides APIs to the services which S1 to Sn, and it also builds a notification payload. So this notification payload, so it contains all the sections like the to whom to send the email, what is the content of the email, and all those, what is the user ID or what is the device ID, and all those information is present in the notification payload, and it is eventually sent to the third party services. So the two main functions of this notification system server is to, first is like it provide the APIs or API endpoints to the services, microservices S1 to Sn to send notification to this server, and ultimately along with that notification it creates a payload and it sends this payload to the third party services to thereby send the notification to the end user. So after that we have this third party services in the flow diagram, if you just remember, which we drew here. These are the third party services. So this, their main function or main purpose is to deliver the notification to end user, and these are highly extensible. This should be highly extensible, so like this can be easily plugged in or removed as per our requirements. And the last or the final endpoint is the iOS or Android or SMS or email. These are the end users, so they receive the notification. Okay, so this is a high level overview of how notification receiving and sending of notification happens. So but this diagram or this architecture has some problems which we are just going to discuss, and you can pause the video and think about it, what could be a problem. Here you can see something is, this is a single element, and you can think of an problem which might arise because of a single element in this architecture. So I think you have paused the video and given it a thought. So let's now discuss some of the problems which we have in this diagram, or in this architecture rather. So the first problem is like, as I have shown you, this is like a single point of failure. So this notification single notification system server acts like a single point of failure. So second thing is like, this single notification server, it handles everything, like it has the database, it has the cache, it also performs sending and receiving notification, etc. So it is very much highly CPU intensive tasks and all it performs, and thus it is hard to scale. Third, we have like performance bottleneck. So what is performance bottleneck? Like it is very resource intensive, right? So example, single notification server handles concurrent tasks to send SMS, email, mobile push notification for order updates, etc. So CPU utilization is very maximum. And moreover, it also blocks network input output to connect to push notifications, APIs, etc. So it's very much difficult to scale, and it also provides a performance bottleneck. Right. So in order to overcome these problems, so we have certain solutions which we can introduce in our architecture, and thereby it will be a good to go solution. So like first is like separate the database and cache from the server. and use it as a different component outside the server and interact with that cache or database as per our requirements. Now to scale performance, or the CPU utilization has been reduced, some performance load has been reduced on the notification server. We can now easily scale these servers and introduce more amount of server whenever required, whenever a huge amount of notification has been pushed or API request has been done. So introduce more number of servers. So this is basically a horizontal scaling which we are talking about. And another thing is, like, we can, to reduce the load on the notification server, we can decouple the components. We can decouple the system components. Like how? So what we can do, we can introduce something like message queues and push notification into these queues, which in turn are used by the workers to pop out the messages from that queue and send them to the third party services, which in turn handles the delivery of notification to the end user. So by introducing these components, we can reduce the load on the notification system server and thereby improve the performance of our notification system design. So what notification system does is, like, it provides APIs for our services to send notification. And so let's write down, or let's summarize what are the tasks performed by our notification system. So one is, like, it provides API endpoints for services to send notification. So it carry out basic validation. It carries out basic validation for emails or phone numbers. It also query database or cache to fetch data and put notification to message queue for parallel programming. So these are some of the points which the notification server handles. The notification server provides some of these functionalities like API endpoints. It carries out basic validation of the user IDs, its email or phone numbers, etc. It queries the database or cache to fetch the data in case suppose the notification delivery has failed and we need to resend the notification and all. So this is basically what we use. So if we dive deep into the details, what does this database stores is, like, it stores the history of the send notification. For a field notification system, it helps in retrying mechanism, personalized settings, like the user wants the notification to be delivered in a certain period of time, or it wants notification only to be in form of SMS or email. So personalized settings, we can store all this information in the database and thereby personalize the notification for a particular user. And what does this message queue helps us, and what, so if we see this new component which we decoupled from our notification system and introduce this new component like message queue. So how does this help us is, like, it removes dependencies. First of all, it reduces the load on the notification system server. So it remove dependency between two components. It acts like a buffer when high volume of notification is to be sent. Thereby reducing the load on the notification system server. And it also helps, like, each distinct message or each distinct type of notification has its own message queue. Like iOS device will have its own message queue, and Android devices will have its own message queue, and I like that SMS will have its own, email will have its own, and thereby if one of the services down, if suppose iOS service is down or APN is down, it would not affect the delivery notification or delivery of notification for other users or other end users like Android or SMS and something like that. And so this is an added advantage of introducing a message queue. So each notification system or type will have its own distinct message queue. And another is like to pull out the notifications from the message queue and send to the third party notification system services like APNs or FCMs or SMS servers, etc. So these worker nodes are introduced. So they are basically the servers which pull the notifications out of message queue and send to third party services. So these are overall the components which we introduce to smoothen our design or to reduce the problems or to address the problems which we face in our initial designing of notification sending and receiving flow. So if we just look into an high level diagram of how this high level flow diagram of how notification sending and receiving occurs, you're introducing these components, you can check, you can have a look. So I'll share a flow diagram here. So yes, so basically this is the overall diagram which we just discussed, introducing the solutions to reduce the load on the notification servers like single point of failure and it was like hard to scale by separating the database and the cache, introducing message queues to reduce the load on the notification servers and all. So how does basically this thing happen? So if we discuss the flow of receiving and sending and receiving notification is like the servers or the services called APIs provided by these notification servers to send notification. So notification servers, what they do in turn is they fetch the metadata such as user info or the device token and notification setting, personalized setting from the cache or the database which we discussed earlier. After that, the notification event is sent to the corresponding queue. So if it is for an iOS notification, device notification or an Android device notification, it is sent to the corresponding queue for processing. For instance, an iOS notification is sent to an iOS PN queue. Then workers, what they do is they in turn pull the notification from these message queues and send to the third party services. After that, the third party services send the notification to the end users. So in this way, a high level flow of notification happens in the system architecture. So in the next video, we will be diving deep into the details of each of these individual components. So thank you for watching this video. I'll see you in the next video.